Okay, yeah. So from today we'll be starting matrix. It is the least minimum required topic which you need to in the linear regression, because we are going to learn the MLR, the multivariate linear regression, in which we have multiple variables. So we have to must know the matrix, the concept of matrix, so we can get the data or clear all those things which we need to. Okay, so we'll be starting from the matrix and what a matrix is actually. Okay, yeah. So set of number arranged in rows and columns so as to form a rectangular array. Okay, so what is said in the definition is what clearly you can see here. Okay, so what here is, it says that it is a set of number. Okay, there not only can be number, there can be character and anything, but what you can do is that you have a lot of things. So you what you can do is you have a set of rectangular field where you have sort of numbers and all the symbols you store in an array. Okay, so we have a number in the row and column. So if you don't know what row and column is, first of all we need to know that what row and column is. Okay, so what do we call row? Okay, so row, which is vertical, okay, which is horizontal, what, which is horizontal, and what column is, which is in vertical. Okay, what horizontal is like this, and what vertical is like this. Like I'm confirming that you would have studied in your school. So yeah, yeah. So what row and column is, you got the what row and column is. Now what we do, did we create a kind of a box like this. Okay, like not fully we cover it, just we make it, assume it is a rectangle. So what we do actually, that we make a rectangular type here, and we put number inside it. Okay, we put number inside it. As you can see, we have 1 0 5 in our one row. Okay, it is a row. If you talk about the row, okay, let me write it if you like. Okay, let me, yes, yeah. If you talk about the row, then this is our row. This is row here. This is the first row, this is the second, sorry, this is the second, and this is the third. Okay, if you talk about the column, this is the first column, this is the second column, and this is the third column. So this is the 2D array, what we call two-dimensional array. Two-dimensional array. Okay, 2D array, two-dimensional array. Got it, right? This is the two-dimensional array in which we have two axes. Like if you can see, then we have the x-axis and y-axis in the form of column, and x-axis in the form of in the row. Okay. Now we have numbers like 1 0 5 9 2 7. This is one row, this is one row, this is one row, and this is the one column. Okay, this each are column, these each are column, and these are row. Got it? Now this is the size of the matrix, which is 3 into 3. Okay, what it is, 3 into 3. What means is here that there are 3 row in it, and there are 3 column in it. Okay, that's how we represent the size of array, the matrix. Okay, and if we have to get the take the position of here. Okay, how will you get the position of this one? We'll get the position of a. Okay, so first of all we have to see how do we represent it. We represent it in a capital character. Okay, in any capital character we represent it by any capital character code. It is a protocol you have to follow, because you were not born before them who created this, so you have to follow. So if you have to put position this element, okay, we can say this is element of the part of this thing. So if we have to position this, then what we will do, that the name of the array, which is a. So what we'll do, that if we have to go to a1, what will you do, a, the name of the matrix, and first of all we write the row. Okay, this I represent the row and j represent the column. This I represent the row and j represent the column. Okay, yeah. So how will you position this one? We'll position by a I, which row, in which row it comes, in the first row, in the first row, and which column first. So a11 equals to 1. It is the position, it is not the value. It is the position of the value which is located. Okay, so we position the value where it is located, and even and on the location we go and we check there is one. Yeah, there is one. Okay, Have you got it? And you can say it. We have there can be many dimension of array. Like okay, this is a two-dimension array in which we have x and y axis, but we can have a matrix where we have only one axis. Like let's suppose from the axis, or we can say one dimension. Okay, so like 1 2 3 4 5 and dot 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 till n. Okay, we have n row. You can see the first, second, third, fourth, blank, blank, blah, 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 and but we have only one column. So this is called a vector. Okay, so this is one call we vector. How vector? If we have studied in, then what a vector quantity is like, which have direction and magnitude. Okay, which have direction and magnitude, but it is not in the case here because it in the physics, but it is not here. Okay, which has direction and magnitude. Sorry, magnitude. Magnitude is some kind of value. Okay, so it holds some kind of value, but so what we can say here, that the matrix which is of only one dimension, which has only one which can have only one row and multiple column, and only one column and multiple rows, we can say it is a kind of vector. And how do we represent vector? We represent vector by a small character, and we give this symbol. Okay, the symbol of like moving forward, like arrow of forward. So this is kind of a vector. Okay, clear, right? Yeah, so we can have multiple ways of matrix. Okay, so we're not gonna like study matrix specifically. What we're gonna learn actually, that how much we should know that we can use it in the MLR, which is multivariate linear regression, in which okay, so we have a concept. Because let's suppose the data we have, okay, we're gonna get the data. So how the data will be, like it is in the form of like this. Okay, so we have some kind of heading here like number, serial number, or let's suppose some like there will be x1 the feature 1, we have the x2 the feature 2, okay, the x3 the feature 3, and blah 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 till like many features. And at last we will have the label it. Okay, the label, the output. Okay, the label, and these all are features. Okay, so if you have, and you have a lot of, okay, the data here, data, a lot of data. So how will you get rid of the data? How will you manage all this data? How will you uh, process the data, right? So that's why we need to know the concept of matrix, because we have the data in the tabular form, so we need to know. Okay, now we'll have some operations on this, which are like addition, multiplication, subtraction, because it is a form of number. Sorry, because it is a form of number, so we can also perform the operations, which are addition, multiplication, subtraction, which I'm gonna like tell you how does it work, how we can do it. Let me clear it. Yeah, okay, the first concept we have is addition. Okay, the first concept we have addition, in which we have a matrix A. Okay, in which we have a matrix A. Let's suppose it has a value of 1 1 1 1 1 1 1 1 1. So can you tell me that how the what is the size of the matrix? Yes, it is 3 into 3. What it is? 3 into 3, 3 row and 3 column. 3 row and 3 column. Okay, this is the 3. 1 2 3 1 2 3. This is a matrix A, and this is the matrix B. Okay, this is the matrix B, in which we have, let's suppose the element is 1 2 3. Okay, 1 2 3 1 2 3. Because not like you can have any number, but let's suppose for the like ease of calculation we are choosing the only right numbers, and like small numbers. So we have like ease of calculation. What you need to understand is the concept that what is being done here, not like how we can do with the large number. You can obviously, but if you don't know the concept what is being done, then how will you do it? Yeah, so how will you do it? We need to add this. How will you add a plus b, which will be 1 plus 1 1. Let me write it first. 1 1 1 1. This is like this, this is like this, and we will add, we was 1 2 3 1 2 3 1 2 3, and their resultant, the result would be, how will you do it? How will we do it? That we will add the first element, the first row, the first column of the first matrix, the matrix of A, with the first row and the first column element of the first row and first column. Okay, and we will do the same with this, same with this, and okay. So what we're doing here is the addition part. How will you do it? So 1 plus 1 is 2, 1 plus 2 is 3, and 1 plus 3 is 4. This, and for same we have all those same. Okay, so we will 2, 3, 4, 2, 3, 4. Okay, you can see that like the result would be same. So can you tell me the size of it? Yeah, it's again 3 by 3, and the resultant matrix is 2, 3, 4, 2, 3, 4, 2, 3, 4. Right, the resultant matrix is 2, 3, 4, 2, 3, 4, 2, 3, 4. That is how we add. Okay, so now you have the question, you have raised a question that can only we have matrix which are of same size? No, 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 it is not. We can have matrix which are uh, in irregular of their size in the addition. Okay, in the addition we can have like matrix which are not of the same size. Let's suppose we have this. Okay, let's suppose the previous example, which is like, let's take this 2, 3, 4, 2, 3, 4, 2, 3, 4, and let's call it C. Okay, now we have a matrix D which is of this size. Okay, which is of this size, which is actually, let's suppose 1, 1, 1, 2, 2, 2. Okay, this is the thing we have. Now we have to add it, and we'll add it. Okay, I don't think, no, yeah, this is how we'll do it. Okay, now we can add a vector to it. Okay, so let's suppose the vector D, we have that. And how will we do it? We have like, let's suppose 2, 3, 7. How will we add it? With this, with this, and with this. So the resultant matrix will be C, 2 plus 2, 4, 5, 6, 5, 6, 7, and it will be 9, 10, 11. Yeah, this is the resultant matrix of what is it is. It is C plus vector D. Okay, C plus vector D. So yeah, we can add vector also, because vectorized form is also very important, because we are gonna have like the, how will I say that, the parameters. Okay, the parameters in the form of the thetas. All the thetas are gonna be in a vector form. So of course we have only one values of theta which are in the like n numbers, because if our feature is of n number, then we're gonna have parameters of n numbers. Yeah, right. So yeah, this is, and the subtraction. Okay, subtraction, that's how the subtractions work, like the same as the addition works, like that the subtraction work. But we don't have to focus on subtraction addition. The main focus we are going to have with the is multiplication. Okay, the most important part we have to do is multiplication, cause this is the main thing. Okay, so of matrices multiplication of matrices. Okay, so let's suppose we have a matrix A. Okay, which is of 2, 3, 1, 0, 5, 2, 6, 3, 1. Okay, this is a matrix A, and let's say we have a matrix B, which is, okay, so let's write the size is 3 of 3. Okay, now we have a matrix. Let's say it's 1, 0, 3, 2, 5, 1, 2, 5, 1, and 3, 2, 1. Let's keep it simple for the ease of calculation. So this is 3, also 3. Now we have a condition here for matrix of multiplication. For the matrix is the column of the first matrix. Okay, the number of column of first matrix, which is 3 of A, should be must be equal to the number of row of the second matrix. Okay, have you got it? Let me repeat it again. The number of column of the first matrix must be equal to the number of row of the second matrix, which is 3 and 3. Okay, we can see which is 3 and 3. If we have, let's suppose, if we remove these from the, if we remove these all, then can we have the multiplication also, then we can do the multiplication After that, yeah, of course we can, because we have the same number of row here and column here. We have the same number of column and rows. So yes, we can do it. We can actually do it. So how is it done? Let me show you. How is it done? Let's keep this aside. So how will it done do this? That the first element, which is the first row and the first column of the first matrix, we multiply by the first row and the first column of the second matrix. So how it is done? It is like 2 into 1. Okay, 2 it is 1, 2 into 1 plus this with this, which is 3 into 2 plus this with this, which is 1 into 3, 3. What do we get? Is 2, 6 plus 3, 8. It is 2, it is 6, it is 2, it is 6, it is 3. Okay, so it will be 11. What you got? 11. Now the same we will do this, okay? The same we'll do with that 0 with 1, 2, 5 with 2, and 2 with 3. So it will be gonna like 5, 2 into 10, and 2, 6, 16. It will be 16, because if we multiply 0 with 1, we're not gonna any number. Okay. Now the third we're gonna get is with the third element, with the third row, we're gonna do it same with this. It is 6, it is 6, and this is 3. It is 15. Okay, what it is? 15. Now the matrix we got, it will be 1, 3 into 1. Okay, it will be same as, okay, so how can we say? It will be the resultant matrix. Okay, so the resultant matrix would be the size of the resultant matrix would be the size of the resultant matrix will be so let me write it here, number of row of first matrix into number of column of second matrix. Okay, so according to this, what we have is the number of row of the first matrix, which is 3, into the number of column of the second matrix, which is 1. So the resultant matrix would be 3 into 1, which we are saying here is 11, 16, and 15. So eventually what we got here, the size of the matrix is 3 into 1, which is like the product of number of row of the first matrix and the number of column of the second matrix. This is how we do the multiplication. Okay, now we have like more concepts like vectorization. Okay, we have like uh, determinant, adjuvant, and a lot of like matrix, types of matrix, skew matrix, and like a lot of things, but we don't have to read that much. We only need to know the basic things for like doing the operations in the MLR, which is our multivariate linear regression. So how will we do it? Because like we'll having, if I give you the overview of that, then we'll be having like, okay, we'll be having some data like this. Okay, so we'll like make sure that this is kind of data. Okay, so this is a position. Okay, we don't know the value here actually, but we know the position, which is like this till the x around to the, this is the first one, this is the p, and this. Okay, so this is this on, like we can say this, let's suppose we don't know. So this will be the first column, and nth row for this is this, and this will be the nth row and pth column. Okay, so it will be like n into 1. Yeah, this is how this matrix will look, which will be n into p, because we have number of row is n and the number of column is p. So this is the matrix of the data. This is the matrix of the data which we have the features. Okay, the more reliable this one will be features. So the number of features we have, now we will have some the feature, let's say it x. Now we will have another, which is the vector will be theta. Okay, the vector will be theta, in which we will be having vectors. We'll be having all the thetas, which are our parameter, theta 1, theta 0, theta 1 till around to the theta n. okay, or we'll say theta p, okay, because we have to, as I've shown you, as I've told you, as it is, that it will be this, it will be this, it will be this, all those, like, okay, like this. So we need to have p number of uh, parameters, or the theta, for like multiplication of the first row, which has p columns. Got it? Then we'll having storing in the another vector, okay, another vector, let's say y what it is, y vector, vector y, where we'll be having all those y1, y2, sorry, y2 till yn, okay. So this is how we'll do it. So I have shown you that how do we multiply the matrix, the multiplication of it, how it is done. Now we'll be using it in the MLR, and I'll be thinking like tomorrow I'll be also doing the matrix, and from over tomorrow we'll be doing multivariate linear regression, because I'm like understanding what are the code I've written. So I could also tell to you, I could also share it with you. So yeah, had the great time with you. So yeah, peace. Let's see you another time.